Hello everyone, welcome back to the online classes, class 10, physics. So we were studying the chapter magnetic effects of electric current, and today we'll learn how an electric motor works. So an electric motor is a device which is used in many appliances like a fan, washing machine, and then devices like computers, MP3 players, in CD writers, etc. So electric motor is very useful and mostly used device. Basically what happens, an electric motor turns the electrical energy into mechanical energy. That means if we pass current through any motor, the motor helps to make objects spin or move in its axis. Means the main work of the motor is to move objects, spin the objects. So just simply considering a fan, when we turn on the switch, the fan starts to move. So inside the fan there is a motor which makes it move. So let us see how an electric motor works. So first of all, electric motor has some parts, some basic structure in which there is a magnet, is rectangular coil, means the rectangular solenoid which is in rectangular shape, and it is connected through with all these parts through an axle. Means axle is a type of a circular rod which helps to hold the things properly. And electric motor works on the principle of force generated on a conductor due to electric field, or force generated on a conductor when it is placed in a magnetic field. That topic we learned in the previous video. So let us see how it works. So first of all, inside the motor there are two magnets, means two poles of magnets, north and the south pole, and inside this pole, the coil or the rectangular coil or solenoid or armature is placed. This is the rectangular coil which is placed between the two poles of a magnet, north and south. This is our armature, or A, B, C, D. This is known as armature. Or rectangular coil. Then this armature is extended down like this, and within this armature, inside this armature, actually there is a rod which is known as an axle. This is the axle, which is basically a circular rod, and these connections are passed up to here. Around this rod there are two rings. Like for example, if this is a rod, for example, just imagine if this is a rod, there are two rings holding the rods like this. These rings are not complete, these are not full rings, they are actually known as split rings, means they are half of a ring. So these split rings are placed one here and one here in this part. Then these two points are connected to the split rings here through brushes. There are two brushes. Brush means simple brush, metallic brush, and these brushes are connected to the power source. Now first let us look how these split rings are connected. For example, this is the rod. The split rings, one split ring means the split rings are actually around the rod. One split ring is here and the other one is holding the device or the rod or the axle like this. They are around the rod holding the axle. This is just the axle, and over these split rings there are two brushes. Brush means that simple brush which we use. So these are actually metallic brush. The brushes which you use in painting are basically brushes made of some hair-like or fiber-like structure. But these are metallic brush which have metallic bristles connected to here, and one brush here connected metallic bristles connected here. So these brushes are connected to the power source and to the armature. Like this it is connected. This two goes to the power source and this two and goes to the armature A, B, C, D. Now let us consider here. So let's see what are the parts. So this is the axle. This is the brush. There are two, both are the brushes, and this is our armature which I have marked there, and this is our battery which will provide voltage, and this is our key. Now when the circuit is turned on, when it is on, current will start to flow through the wire. Current will go through the wire and finally through the brushes the current will go to the coil A, B, C, then B, and again the current will come back. Current will flow like this and then it will finally reach the negative terminal of the battery. Now let us see how this works. Now first we will consider the direction of current in side AB. Now here we will apply the Fleming's left hand rule. Current is flowing through the circuit, going to the coil. This is our coil armature. Now see here, the magnetic field is flowing from north to south. So this is our magnetic field, and then current is flowing upwards. The current is going up. If you remember, the forefinger shows magnetic field, the middle finger shows electric field, and the thumb shows the direction of motion. So the current magnetic field is going from north to south, electric field is going up inside AB. We are considering side AB, and then the force, which is our thumb, is pointing inwards. That means this side will try to move this direction, means it will flip. This side will go down, AB side will go inside the board, if you consider this diagram. Now let us see side C and D. In this side, magnetic field is going from north to south, electric field is going downwards like this, and the thumb, which is showing the force, is pointing towards the camera. It's moving out of the board. So this side CD will flip up. This will go down, this will flip up. So basically it will act or work like this. For example, this is our rectangular coil A, B, C, D. A, B, C, D. Now confirm this like here, placing it here in front of the coil. North pole, south pole, magnetic field going from north to south, electric field is going from down to up like this, and this is force is inside. So this side will turn like this, and similarly in the other side, using the same Fleming's left hand rule, this side will flip like this. So as a whole, when this is connected to an axle, this rectangular coil is connected to the axle, this axle. So here it will flip or turn like this. So what happens? A side flips to C and CD flips to this side like this. Now comes the work of the split rings. These split rings. So look here. These are the split rings. I am just naming them P, Q. This is P. This is Q. Just I am naming them. P is going to side A, B, C is from C, D, Q is from C, D, that side. Now what happens when the split rings are holding the axle, They are holding the axle like this. Just imagine myself like my this side, my right hand arm is AB, left hand arm is CD. So from AB, from this clip, electricity is coming, and from C, electricity is going to the negative terminal. So when the book will flip, means when the armature will move, so the split rings will also move like this. And finally this side will come here and this side will come this side. So what happens, this will flip like this. So what happens, this side will come here, CD will come to AB, and this will help, this in this part, this axle and split rings will help to move the armature, will have to move the coil easily. Otherwise, if the brushes or the split rings are not there, if it is soldered directly, then while moving the wires will interchange and interlock, and finally it will create short circuit. So finally this side moves and comes here, this side moves and comes this side, and again due to the brushes from here continuous flow of the positive field will go through it, and it will go like this, and again it will, electric field will move out through it. And finally what will happen, this armature will continuously move. Like for example here it is getting positive, this is positive, this is negative, so it will move like this, again this side will get positive, this will get negative, again it will move like this, and finally it will continue moving like in a circular pattern or in a circular form. If it is like this, it will continue to move or spin like this with the help of the axle and the split ring. So this is how an electric motor works. And in this electric motor, these split rings P and Q, the split rings, they work as a commutator. Commutator means any device which changes the direction of electric flow or electric current. So commutator is basically which changes direction of current. So that means previously P was getting positive, Q was getting negative. Now when the armature will move, will turn about, then Q will come this side, P will go that side, and at that time P will get negative current and Q will get the positive terminal. So this much only for today. Thank you.